Welcome to FP Functional Programming Mobile for using Kotlin Multiplatform Mobile for the Rehearsal Pro project. You've been here before. I'm just going to do a quick summary of some work that I just did. It's pretty simple. Basically, wow, there's that basically word, just can't get rid of it. The line sets, they can now be played one after the other, and the lines are now properly sorted. So if we go into a line set here, for example, although notice that the sorting here, we've got the classic problem of string sorting versus number sorting where, and this is actually happening in the legacy app as well. Actually, the sort number that's used here is the correct sort number, but the naming does not quite match. So I'm going to take a look at that at some point, although again, this is the behavior of the existing legacy app, so it has nothing to do with this rewrite. But last time we were looking here, these were out of order. Now if we play them, and we can play.
What do we got?
So this is literally playing this line, goes to the next line in order.
Cause of death was catastrophic internal bleeding and
blah, blah, blah. Go to the next line.
In English, please.
Go to the next line.
Hemorrhaging around the heart.
Hemorrhaging around the heart. So we can see that all these lines, whoops, for some reason the scrolling in the simulator, we go here and we look at the scrolling in the simulator. I have to use 3 fingers. Okay. Yeah, I was using 2 fingers. I think here I used 2 fingers on my MacBook, on my trackpad, but here I have to use 3 for some reason. That's kind of interesting to simulate the touch sort on the phone. Okay, so what did we do? We simply fixed the sorting. We can close this up. I don't think we need to see this anymore. And pretty lightweight set of changes. We can see the original. We had stuff commented out. And this was a call to sorted check lines inside the legacy core data class, which is now in the dead folder. So if we take a look at that, for example, current line set, sorted checked lines, and we find that inside line set plus sorting sorted check lines. So this is the original Objective-C code that provides sorting. You can see we've got a set of different method here strictly for the sake of sorting. It's kind of hard to read. All these long names, check, filter, predicate with format, and init with key, all that sort of just very verbose, very object-oriented, or I should say in this case, Objective-C oriented. Obviously the Objective-C syntax here, which I'm clearly not a fan of. These @ signs and all that. So I guess if I spent more time in Objective-C, I'd find this a little easier to read. The point is, this has been converted to Kotlin. And to use Kotlin instead of the self, since we don't have an object anymore, we're doing it a functional way. We're going through this facade, this adapter, because we're not able to call these Kotlin freestanding functions directly, or I would say we're not able to call freestanding functions directly from Objective-C. So in the domain, we have this facade. So for domain line set, these 2 were added. Line sorted checked. And all they do is they just delegate. You can see they delegate here to the new Kotlin code. And the new Kotlin code looks like this. I find this more readable. This is pretty straightforward. So here we have 2 functions, sorted and sorted checked. We go back and we compare that to the same thing here. So 2 functions, sorted lines, looks like this in Objective-C. Sorted checked lines. So 2 different modes, one that filters for checked and then sorts, and one that just sorts. And that's what we've done here. And I find the syntax quite a bit more readable. Sorted checked, we get the set lines. This function was already there before. We filter and we sort. Filter sorted by. And this is a pure function. It returns a copy, does not mutate this, and does not depend on anything external. So it's in the pure folder, it's under domain. And is this pure over here? Looks pretty pure. I think this qualifies. Believe this is making a copy. Yeah, filtered array creates a new array. In this case, you have to actually declare an intermediate variable and then return that variable. Or do I? No, I shouldn't have to. Actually, I should be able to grab this sub-expression and insert it right in there. So, yeah, this is an example of excessive verbosity that's unnecessary. The language isn't forcing us to do this. The programmer is deciding, I'm going to have this intermediate variable and give it a name. I mean, we can see if we just take this expression and we embed it. This is in the dead folder. It's not going to compile. Let's just assume it compiles. And again, we get this fairly awkward alignment because of the way Objective-C likes to align on the colons. And of course, the parameter names and the method names are going to be variable length, so there's no guarantee on any of this stuff lines up. But let's say we were to do it like that. We wouldn't need this intermediate variable. Still need the return. We still need the block. We still need to declare the return type. But in Kotlin, we get away with, in this case, return type is implied, so we don't specify it at the end. This is an input parameter. This is a function. This is not a method on an object. This is a method on the object, right? So in this case, this self, which is originally this line set core data class, is now simply a dictionary passed into this function. But the return type is implied. It's whatever the result inferred, not implied. Whatever the final type is of the final return. No return statement required. We've got a nice equal. We don't have to have the block. So I'm just kind of comparing syntaxes here. So we don't need this. We don't need that. We don't need the blocks. Filtered array using predicate. You know, Objective-C is an older language, doesn't have some of the newer, cleaner things. I mean, they obviously have the filtering capability, but they decided to complicate it by saying, you have to set up this predicate, and this predicate is of a certain type, and got to format it properly and all that. That goes away over here. Simply this nice, clean filter operation, and which is a method in this case in Kotlin. Right, I can't do anything about that. That's what's built into the language. And then this block is really a parameter that's a closure. We can also do it like this, but again, it's going to complain at us saying, you don't need the parentheses, just use the braces that are defining the closure here. So they prefer this. I find this syntax confusing. To me, whenever I see these braces, I always think this is a block of code executing in a statement-wise fashion. But this also means just a block of code that can be expressed as, in this case, a closure, right? The it is implied by the signature of the closure that expects. In fact, we can see that, in fact, they're calling it predicate. Predicate is a fancy word for if expression. True or false expression is a predicate. A lot of people don't realize that. It sounds kind of highfalutin, doesn't it? But we can see the IDEs telling us what that looks like. So in this case, we're providing a lambda. We could actually provide a defined function as well, as long as it matches the signature of, when the signature is exactly that, taking an argument of the type and returning a Boolean. And in this case, the syntax is condensed because the argument, the type that's passed in, which is the self coming from the result of domain lines, set lines up here, gets filtered. And the compiler's taking care of all the generics here as far as plugging in the correct type instantiation for these generics. But it makes for a pretty nice, clean, it's nice and clean. And I think incredibly readable. The only other function I had to add here was just the sort number. which I make a comment on over here. So sort number is already in the dictionary FID originally as JSON, comes down as with a key of NS from the back end. But we can't cast this directly to an int because if we're coming in as an any, and as it turns out, I had to do some debugging to figure this out. I really wasn't sure what Kotlin was going to map from an NS dictionary on the Swift side. So remember, this is coming in originally on the iOS side from the network as JSON data. The networking layer then automatically converts to an NS dictionary. So when an NS dictionary is passed, in this case, we're passing this NS dictionary, we know that the type that it gets mapped to is the type that it gets transformed to is what Kotlin calls the dictionary, which is a map with strings and any's that essentially matches our definition of dictionary string any. We've already talked about that a lot. But the question is, in the contents of the dictionary, which is other dictionaries and other types, what is that any type actually, right? So any is an anonymous reference to a type. We don't know what the type is, but it is a type. And if we try to cast this down to integer or int, it's going to fail because the actual fundamental type, it turns out, is a string. So we have to first cast the any to a string, and then from there we do a conversion to integer from string. So it's being stored, it's being represented in memory as a string. We want a number. We're going to do the or null. If we don't do the or null, we've got a possible exception in here. If it fails, we got to put try catch in there. We don't want any exception throwing and handling in here. We prefer to use the or nulls, and then we just default it to 0 if it's can't convert. I suppose we could default it to -1. But since this is a sort number, yeah, I don't know, that makes a lot of sense. Not something I'm going to worry about too much. Okay, so we added that. We added the simple sorting things, and that means we have no need for this original Objective-C code. And this was the sort for line seen, so we don't need either one of those. And all we ended up doing was plugging it in here and plugging it in down here. We saw this original comment was expects to be sorted, so we added that sort to it. We added the adapter. And that's it. And that's all there is. It's that simple. I think there was a change before that, actually, that I did not cover. Let me just take a quick look at that. There is a previous commit. Yeah, let's just take a quick look at that. Let's go back to this branch. I think it's the last video. I'm not sure I showed this commit. No, this is all the stuff we talked about. Yeah, this was the last thing we dealt with. Yeah, all right, that's it. Enough said. Nice and short. I wish you the best of luck.